What is building orientation? Designing for building orientation is a fundamental step to ensure that a building works with the sun's path across the sky. Knowledge of the sun's path for any site is essential for designing building facades for light access, passive solar gain, and reducing glare and overheating. It is important to remember that the position of the sun in the sky is always changing according to the time of day, time of year, and the site's latitude. Building orientation focuses on the practice of facing a building in a way to maximize certain aspects of its surroundings. This includes street appeal, capturing a scenic view, and drainage considerations. With rising energy costs, it is becoming increasingly important for builders to orient buildings to capitalize on the sun's free energy. Orienting a new building will take advantage of the warmth of the sun to increase the building's appeal and marketability. This will increase users' indoor comfort and reduce energy bills. Well-oriented buildings maximize daylighting through building facades, therefore reducing the need for artificial lighting. Buildings that maximize sunlight are ideal for the incorporation of passive solar collection techniques that can reduce carbon use and enhance user comfort. A careful strategy can also mitigate overheating and glare when sunlight is excessive. It is important to know how the sun interacts with buildings in high summer and the depths of winter. Factors that affect buildings' orientation. The relative position of the sun is a major factor in heat gain in buildings, which makes accurate orientation of a building a fundamental consideration in passive solar construction. Most importantly, a building's ridgeline should run east-west to maximize the length of the southern side. Buildings reoriented towards the sun without any additional solar features save between 10% and 20%, and some can save up to 40% on heating. Builders should note that these directions are given in reference to the sun and not magnetic north, which can vary significantly from the sun's actual position. Building in temperate regions can benefit from admitting the sun into buildings' interiors. Openings should be oriented southwards and consider the use of conservatories and buffer spaces. Office buildings focus on the reduction of excessive solar heat and glare. This is because a greater majority of offices have glazed facades and higher internal gains from people and computers. Glazing due south should be used sparingly and incorporate shading devices. Another environmental factor that should be considered in the equation of building orientation and positioning is prevailing winds. Prevailing winds are winds that blow predominantly from a single direction over a particular point. Data for these winds can be used to design a building that can take advantage of summer breezes for passive cooling. They can also shield against adverse winds that further chill the interior on an already cold winter day, or even prevent snow from piling up against windows and doors. Modeling light. Many older home designs were oriented through the use of a heliodon, which is a movable light source used to mimic the sun's path that hovered over a small-scale model of a proposed building. Today, mathematical computer models calculate location-specific solar gain and seasonal thermal performance with precision, and have added the ability to rotate and animate a 3D color graphic model of a proposed building in relation to the sun's path. Tips for new construction. Orient the floor plan with all adjacencies considered towards the sun. Design the building so that the most frequently used rooms are on the southern side. Patios and decks should be built on the south side of the building, where direct sunlight will permit their use for more hours during the day and more days during the year. In a house, the garage, laundry room, and other less frequently used rooms should be situated at the northern part, where they will act as buffers against the cold winter winds. Install as many windows as possible. The exact number of windows required is different for each house or building because it considers the local climate. A sun-tempered building should include enough glazing to equal 5% of the conditioned square footage of the building. However, windows allow heat transfer more easily than walls do, so many windows can actually drain heat from the building during cold winter months. Plan for tree shade. Trees are an important factor in passive solar design because they can provide needed shade on a summer day. Conversely, if trees are not planned for the correct area, they can potentially starve the house of natural light when it is needed the most. Deciduous trees planted on the south side will lose their leaves in the winter and allow natural light to enter the house, while evergreen trees planted on the north side will provide shade from the summer sun. Builders should carefully consider the age, species, and growth rate of existing trees before deciding where to orient a structure on a building lot. Ultimately, factors such as street appeal and the property's lot dimensions may restrict a builder's ability to orient a building in strict accordance with passive solar techniques. Even while working under these constraints, however, a builder can still create an energy-efficient home through the implementation of energy-saving features such as low E windows, adequate insulation, air sealing, and cool roofs. Overall, homes oriented to the path of the sun will require less energy for heating and cooling, which will result in lower energy bills and increased indoor comfort.